How many of you have insurance on your car or motorcycle, right? You have deductible, right? What, you know what your deductible, how much? 500. Usually there's 300, 500, or you can really go, I want zero deductible, then you have to pay more money. So, but usually when people have, especially if you have homes, some of you probably don't have homes, your parents might have it, but if you have a house, you probably want to have your house insurance and your car insurance with the same company. And your deductible might be different for each one. The house deductible might be 500. So let's define X as the deductible amount. And we'll say that's on your auto there. Auto policy. And let's define Y as the deductible amount on your home policy. So Y is your home, X is your car or your motorcycle. So let's define, and usually these deductible, we'll just throw some numbers. There could be 0 deductible, there could be $100 deductible, or there could be $200 deductible. Could be 500, 1,000. And X here is your auto. And with the auto, we'll say there's either $100 deductible or $250 deductible. This is the auto here. Y is your home. So usually when people have low deductible on their home, they probably have low deductible on their car too. But let's say we did a study, we asked people, how many of you have low deductible on this? And we calculated what the percentage. We found 20% of the people have 0 deductible on their home and $100 deductible on their car. We found out this is only 5% of the people who have low deductible on their home but high deductible on their car. We found that 10% of the people have 100 on the home, 100 on the car, 0.15, 100 on home, 250 on their car, and 0.20, 20%, and 0.30 for the other one. Now this is known as joint probability distribution function. This is the probability of X comma Y. Now again, for this to be a valid probability distribution table, if you add, to be a valid table, if you add all these probability, the summation over X and over Y, it should be a 1. So if you add all these numbers, they should add up to the 100%. 0.25, 30, 40, 50, 70, 100. Now let's look at something called marginal probability or density. Which means, can you give me a breakdown on the probability for X only? Or what's the probability for Y only? And when you want to find the probability of X, you add the summation over Y. And when you want to find the probability of Y, you add the summation over X. So what does that mean? Add the summation over y. When you try to find the probability over x, so you gotta look at the x value. X, your deductible is what? Could be 100 or it could be 250. That's it. And what's the probability of x? That's what that answer is. So we try to find out, okay, what percent of the people have, for x there's only two options, $100 or 250. So what percent of the people have $100 deductible on their car? We add these numbers. That's why we say we add them over y. So it's 20, 30, 50%. What percent of the people have a $250 deductible? 5 and 15 is what? 20 plus the 30, that's also a 50. So that's your P of x of x. That's this function. That's that table. What about the probability with respect to y? For y, you have three options. You could have 0 deductible, you could have 100, or you could have what? 200. For 0 is 20 plus the 5, which is what? 0.25. 0.25. For the 100 is also 0.25. And for the 200, we have 50% of the people. We add them over the x values. We add all the x values in that column. So if you're trying to find the probability or the percentage of people who have 100 on their car or 250, you only have to look at that table. If you have to find the probability with respect to y, you only have to look at that table. For y, you have 0, 100, and 200, and that's the probability of each one. Now let's change that now to continuous. That's just to see it in discrete. What about continuous? We define f of x comma y just like p of x comma y is the probability of density function. The probability here. F of x comma y here is really your probability, but is known as the joint because it deals with two things. Joint probability density function. And for that to be a valid function, just like the discrete one, for the discrete we said what? The summation has to be 1. So guess what that means here? To be a valid density function, if you double integral that function, if you integrate twice over x and over y, the function of x comma y, dy dx or dx dy, it doesn't really matter which one you do first, the result should be 1. So an example. For example, if you take Bank of America, when you go to the bank, there's two ways to get to the bank if you want to get some money out. You can go to drive-through, or you can go inside to speak to a teller, right? Either way, you probably have to wait. So let's define x as the time, wait time, when you drive through. And let's define y as the wait time when you go inside. You stand in line. When lady said, can I help you? Or the man said, can I help you there? And you walk in to get some help. That's the wait time, how long you waited there. And I'm assuming, I hope the wait time is not in hours, you know. Let's say the function was given to us, the wait time, the joint density function for both is the function which is some constant times x plus y squared, where x between 0 and 1, assuming it's 1 hour, that's a long wait there, and the y value between 0 and 1, and 0 otherwise. And my first question, what value of k, that's a constant, that will make f of x, y a valid density function, valid joint probability density function. What value of k? So what do we do? How do we know it's valid density function? We double integrate that over the limits, and the answer should be what? 1. So let's double integrate that. X is going from 0 to 1, y is going from 0 to 1. I took the k outside because it's a constant. Dx, dy. Now, if you remember your integration, when you integrate with respect to x, is that calc 3 here now? Double integral? So you hold y as a constant. This will be x squared over 2 plus y squared times x, as x goes from 0 to 1, dy. So when x is 1, you'll have 1/2 plus what? Y squared. When x is 0, that's a 0, dy. And you want to make sure your answer is equal to 1 to be a valid density function. So let's integrate that with respect to y. That'll be 1/2 y plus what? Y cubed over 3 from 0 to 1 when y is 1, you will have what? 1/2 plus 1/3. When y is 0, 0. LCD is 6. K will have to be what? Is it 6 over 5? So if you let k equal 6 over 5, that will make your density function a valid density function. Now, curiosity, how often, or what's the probability that if you walk in, it's going to be the x value, you're going to wait between 0 and 15 minutes, which is a quarter of an hour, and if you go, which one's the one, which one, I forgot which one's which, x is drive-through, and y is the teller. And also at the same time, drive-through was between 0 and 15 minutes wait, and the teller was between 0 and 15 minutes wait. What's the chance? How often that happens?
Are you solving for the function equals 0.25?
0.25, correct. So that will be the probability equals the integral from 0 to 1/4, or 0.25, for both. And we said the function, now we know what k is. Was it 6 over 5? So it's 6 over 5 x plus y squared dx dy. What is the probability if Bank of America, anytime you walk into it, that you only have to wait less than 15 minutes for either the drive-through or the teller? Again, I can actually cheat here. If I don't want to integrate this by hand, we know how to integrate by hand. If I remember my TI-89, go F3, which is the integral. That's the second one, integral. That's the first integral. I hit F3 again, second integral. And the function, I gotta write the function. I'm a big fan of parentheses. So a parentheses 6 divided by 5, which is 1.2, times, make sure you put the times, another set of parentheses, what was it, x plus y squared? X plus y to the power of 2, close parentheses, comma, do x first, comma, x goes from 0, comma, to 0.25. Close the first integral, comma, the y value, comma, 0, comma, 0.25, close that. And if you see the integral there, I don't know if you can see it. Can you see that equation? Is that the right integral? 0 to 0.25, 0 to 0.25, 6 over 5, x plus y squared dx dy is 7 over 640. So it's equal to 7 over 640 if you want it as a decimal value. Hey. As a decimal value, that's what? 0.010938. There's a 1.1% chance that the waiting will be less than 15 minutes. Now again, that could be less than a minute, a quarter of a minute. If I ask, what is the probability that x will be between a quarter to 3/4 and y will be between what? 0.5 to 0.75, 3/4. They don't have to be the same limits. So again, that becomes from 1/4 to what? 3/4. That's 0.75. That's the x. I put x first by mistake, but that's okay. 1/2 to 3/4 x plus y squared. I have the constant. I forgot to write it. Do the dy first, then the dx. Again, I can cheat now, go to my equation, just change my limits. X goes, instead of 0, the first one is what? X goes from 0.25, where's the insert key, comma, to 0.75, close that, comma. Y goes from, comma, 0.5, comma, 0.75, close that. I just wrote them backward. I wrote Y first. Y goes from 1/2 to 0.75, 0.5 to 0.75. X goes from 0.25 to 0.75. And it's 43 over 320. Which is 0.134375. There's a 13.4% chance that if you walked in, you have to wait between half an hour to 3/4 of an hour for Y, which is the teller, and between 1/4 of an hour to 3/4 an hour for the drive-through. That means don't use your lunchtime to go to that bank. There's a 13% chance that you're going to be there for a while. If that was in minutes, I'll say perfect, you know. Now, what about the finding the marginal probability density function, like these? Can we find them? And the answer is yes. If I want to find f of x, like we call them p of x here, the function with respect to x, which is just based on the x values. We know x goes from 0 to 1 hour. So to find that, that will be the integral, usually over y, negative infinity to infinity. We'll put the right limits when we get to it. F of x comma y dy. And to find f of y, we integrate over x. So for the example we just did, feels like a calc class, huh? For the example we just did, if I want to find f of x, remember your x value, your y value is going from 0 to 1, 6 over 5, x plus y squared with respect to y. Your answer should be as a function of x. That's what your function should be. It's not going to be a number. It's going to depend on the value of x. You tell me how long, and I'll tell you what the answer. So that would be what? 6 over 5 xy plus what? Y cubed over 3 from 0 to 1. When y is 1, that's what? 6 over 5 x plus 1/3 6 over 5x plus, what's 6 over 5 times 1/3? Is that 2 over 5? And x between 0 and 1. So you tell me what value for x, and I'll tell you what the answer is. How long you have to wait. Remember, x was, I can remember it again. X is my drive-through. So how long are you going to wait the drive-through? You tell me you want to know for 0 minutes, what's the chance? That will tell me that what that probability is. 1 minute, that will tell me what the probability is. Anywhere in between, just tell me what the time is. Not minute, hours, I mean. And I'll tell you what the answer is. What about that inside teller? What is the wait time for that person? That's f of y. It's going to be the integral from 0 to 1, 6 over 5, x plus y squared dx. Six over 5. With respect to x, that would be what? X squared over 2 plus y squared x, as x goes from 0 to 1. X. So when x is 1, 1/2 plus y squared is that 3 over 5? And this is y between 0 and 1. So notice that let's assume the question now is, I get this function, and let's say y is the teller on the inside. I could care less about the drive-through. I don't have a car. I'm going to walk inside. So car is not of interest to me, the drive-through window. What is the probability that if I go right now, I'm going to wait on the inside? I'm going to give you some numbers between 1/4 of an hour to 3/4 of an hour. I'm not even mentioning what the drive-through. I'm not interested in that. Jimbo. Okay. Probability, joint density function, continuous. So what's the chance if you walk into the teller right now, you'll have to wait between 15 minutes to 45 minutes. We don't care about the drive-through. This is the drive-through. This is the wait for the drive-through. This is the wait for the teller on the inside. So this will be what? The integral from 1/4 to 3/4 f of y with respect to dy. So this will be the integral from 0.25 to 0.75, 6 over 5 y squared plus 3 over 5 dy. Fun stuff, huh? So this will be 6 over 5 what? Y to the 3rd over 3 plus 3 over 5 times y, and y goes from 0.25 to 0.75. That's 2 over 5 y cubed plus 3 over 5 y. Two divided by 5 times 0.75 cubed plus 3 divided by 5 times 0.75. So the upper limit, at the upper limit I got 0.61875. At the lower limit, let's see, 0.4 times 0.25 cubed plus 0.6 times 0.25. 0.15625. Subtract them. And I came up with this answer, 0.4625. So what is the chance if you walk into a teller at Bank of America and you have to wait between 15 minutes to 45 minutes? You have a 46% chance. Again, these numbers don't bode well for Bank of America. But I made that example up. It wasn't really their problem. Okay. Yep. Let's try another problem.
Thank you.
Okay. Let's bring in some food to this problem. I sure brought the can with me. You go to Stop and Shop, Big Y, any store you shop at, Whole Food, and you get a can of mixed nuts. It's 1 pound can. In that can, normally they have almonds and, I don't know, cashews. X represent the almonds. How much almonds in the can? And Y can be what? The cashews. They mix the nuts together and they put them in the can. Just thinking about that, it is possible a can might squeak by that has all almonds. Just almonds. Right? So we know X could be between what? 0 and 1. Could be. Not a single cashew in that can. Shouldn't be, but they screwed up there. They didn't mix them well. It is possible the can, the Y cashews here, also you might get a can that's only cashews. And again, the chance of that happening, very slim. But usually you have a mixed type together. So you know X plus Y always has to equal to a 1. That's the other condition. It should be really less than or equal to 1. Never always equals to 1. They never go more than 1. So if you want to be technical, say less than or equal to 1. It should be 1, always, every single time. If you're selling 1 pound of mixed nuts, it better be 1 pound that can. So I can make it equal to instead of less than or equal to, but sometimes they put a little bit less. So I can just make that like this. Technically should be that. Because unless you're selling something else, if you're putting almond, cashews, and what's the third one they might have there? Peanuts, yep. Then it could be less than or equal to 1. Because it could be all peanuts, right? But we're assuming just almonds and cashews in these cans. That's it. My least favorite is the cashews. Don't like them that much. Almonds, oh, I love almonds. Okay. Somebody came up with that function that described the almond and the cashews mixed together. And it said we found that the joint density function that represents that happens to be 24 times X times Y. That's it. And again, x is really between 0 and 1, y between 0 and 1, and x plus y has to equal to 1, and 0 otherwise. Now, the question is it a valid density function? Is this, now you're going to use really some calculus. Well, to be a valid density function, we need to double integrate, right? Here we go, the double integral of the function has to equal to 1. And now I have to know what my limits are. Do I write 0 to 1 and 0 to 1 for both of them? Huh? This is x between 0, 1. Well, let's look and see what x is. This is the 1 here. This is the 1. X plus y is this line. We're saying the mixture is somewhere here, in that area. That's what the mixture is. So if you want to put y on the outside, the y value is going from 0 to 1. Where's the x value? Is x going from 0 to 1 here?
Would it be 0 to 1 minus y?
Correct. Now notice this piece, it goes right here. The next piece, it goes right here. The next piece, it goes right there. If you decide to put y on the inside, x on the outside, then you go vertical line. It's going to this, it's going to this, it's going to that. So the x value is going from 0 to 1 minus y. Because if you solve for that, x equals 1 minus y. You're not going to 1. The only time you go to 1 when you're right on this line, because y is what? 0. What's 1 minus 0? You go to 1. But after that, you go a little bit less each time. It's not a 1. So if you integrate with respect to x, this will be 12 x squared y in the first one. And x is going from 0 to 1 minus y. Now, if you plug in 1 minus y there, it makes sense here to FOIL this one out. I'm a big fan of rearranging everything for descending power. I like everything to be nice and neat. Oh, this is 1, not 12. This will be y cubed minus what? 2y squared plus y dy. This will be y to the 4th over 4 minus 2y to the 3rd over 3 plus y squared over 2 from 0 to 1, and multiply your answer by 12. I hope it's a valid density function. I don't know. When y is 1, that will be what? 1/4 minus 2/3 plus a half. When y is 0, that's a 0. LCD is 12. This will be a 3 minus 8 plus what? 6? What's 3 minus 8 plus 6? Is that a 1/12? Which is a 1. It is a valid density function. Now, a couple more things here. Looking at the clock here. What about f of xx, the marginal density function? If I want to find f of x, it's the integral over y, f of x comma y dy. And that will go from where to where? From 0 to 1 minus what? 1 minus x, 24 xy dy. And that will be 12 x y squared. Y goes from 0 to y equals 1 minus x. And that'll be what? X squared minus 2x plus 1 multiplied by 12. I'm going to write the whole thing as 12 x cubed minus 24x squared plus 12x, as x goes from where to where? From 0 to 1. X represent what here? I forgot. Is X the pistachios or the almond? Cashews or almond?
Almond.
Almond? Okay, X is the almond. So if you want to know what is the probability of having 50% almond or 30% almond or between this number and that number, we can just plug it in. What is the probability of number of the almonds will be between 0.2 pounds and 0.4 pounds? What's the chance? It's probably high because cashews are more expensive. So in most stores, probably almond, the can has more almonds than cashews. So for the can to be between 0.2 and 0.4, actually won't be high because we expect the almond to be more than half. So that might be a lower number. So if you want to find the answer to that, you go, well, I'm dealing with the integral here. This is from 0.2 to 0.4 of this function. So that would be 3x to the 4th minus 8x cubed plus 6x squared. X goes from 0.2 to 0.4. Let me try that. F1, 8. 3 times 0.4 fourth minus 8 times 0.4 cubed plus 6 times 0.4 squared. The upper limit is 0.5248. The lower limit
1808.
0.1808.
Yeah.
So we subtract them. Minus 0.1808. And the chance of that happening is 16. Doesn't seem higher than 16%.
34.
What happened?
I think you hit it twice. I think you hit enter twice in the calculator.
Oh, maybe. So it's 43, maybe?
34.4. Yeah.
I'm really struggling with this calc. What was the number today? Point.
0.344.
There's a 34% chance that the can will have between 0.2 to 0.4 pounds of almonds in it. Now the next thing, one more topic here. I'm going to give you some homework today. We might ask you the question, is X or R, because we have two of them, are X and Y independent? And the only way to prove that, if you remember, the probability of X and Y when they are independent has to be the probability of X times the probability of Y if they are independent. Well, that still applies to us here. For them to be independent, that means f of x comma y is equal to f of x times f of y. If you multiply these two, you end up with that function, then they are independent. That's how you testify or validate if the events are independent or not, or test them. If this probability is equal to this, or the product of these two equal to that, then X and Y are independent of each other, meaning the outcome of one does not affect the outcome of the other one. That's not the case in this example. You put in cashews and peanuts in the can. What happens if you put more cashews in the can? What happened to the peanuts? Less. So they can be independent. Now the waiting at the bank we did before, the teller versus the drive-through, they might be independent. They could be dependent if what? If they're next to each other and chit-chatting. So if one is talking to the other one, if one is slow, it's going to slow the other one. But if one, like on this side of the building, one on the other side of the building, it really has nothing to do with each other. So they could be independent. But to find out if they're independent or not, you multiply the probability of X times the joint density of Y together to see if you get f of X comma Y. So let's give you some homework problems to work on.